Hello and welcome to this short video on how to change a pattern into a formula and also how to change a formula into a graph. Let's imagine we're at the X show and the organisers are wanting people to have an area to display their prize bulls or prize sheeps or whatever, and they've decided that they're going to put up little pens using 4 crash barrier gates per pen. Now when they build the second one, it's next to the first one, so they don't need to put 4 for the second one. They just simply add a front, a back and a side, and they can share the middle, and that pattern will continue on. So basically, for 1 pen we need 4 fences, for 2 pens we need 7 fences, for 3 pens we need 10 fences. This pattern can be extended to any number, although that might be time consuming if you have quite a lot that you need to go for. So I've done one more. For 4 pens we would need 13 fences. So the original 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13. That's how I'm counting the fences there. We can put this into a little table. So as you can see, I've got my pens along the top. I'll pick up my pencil because it's probably easier to see than my finger being in the way. My pens are going along the top, so they're going up 1, 2, 3, 4, 5. And what I'm going to do eventually is to work out how many fences I need to make 23 pens. So I populate the rest of the table with 4 for the 1, 7 for the 2, 10 for the 3, 13 for the 4. Now there's a bit of a number pattern happens here. You may have spotted it already, but we're adding 3 each time. This is called the multiplier. So this number here, which it's going up in all the time, means that these numbers are in some way related to the 3 times table. So that's not quite the full story though. So if I go 3 times 1, I get 3. That's 1 short, so I would need to add 1. So what we have is we have 3 times 2, and then add 1 would give me 7. 3 times 3 would give me 9, and then add 1 would give me 10. 3 times 4, add 1 gives me 13. 3 times 5 is 15, add 1 gives me 16. So that means that 3 times 23 is 69, add 1 is 70. So to make 23 pens, I should say, I would need 70 fences. Basically what happens is if I have any number, p, number of pens, I'm going to have 3 times p plus 1. We can plot this in a graph. I have a very small part of that graph drawn where I have fences going up the left hand side, the vertical axis, and I've got the number of pens going along the horizontal axis. When I'm drawing graphs like this, I make things easy on myself by using 1 number per box. So if I plot the 1 pen, so we had 1 pen, we needed 4 fences for that. When we had 2 pens, we needed 7 fences for that. When I had 3 pens, I had 10 fences for that. And when I had 4, I needed 13. Now I don't know if you can see that particularly well, but that forms a nice straight line. Now I'm not going to use a ruler here. I'm suspecting that not everyone might have a ruler at home, but one of the things I've done to get a straight edge is to actually draw a straight line using the edge of a pencil. Now, when I do that, you may notice that the straight line comes through the number 1. That's the number that's being added at the end here, because that makes sense. When I have no pens, 0 times p plus 1 would be 1. Now, we wouldn't just need a fence because we're not producing any pens, but in real terms, that's a nice little catch-all from where your graph is going to run up. I'm going to set a worksheet on this to extend you and to help you get in touch with where you would need to be otherwise in class, and I'll email that all out to you in Glow. Thank you.